Okay, so we have a bunch of angles, alpha, beta, gamma, and an offset, which are just slider values. And from that, a hyperplane is constructed. A hyperplane normal, which is a four-dimensional vector, of course. From the angles, and then a point from the center and the offset slider. And then using that, we can construct a hyperplane. Then they define an arbitrary universe of 4 dimensions, and then a subspace of 1 dimension inside this universe. That is simply along the hyperplane normal. And then I create a basis in this universe of 3 dimensions. And that is orthogonal to that subspace that we just created. So then we have our 3D volume, or immediately even a basis for it, where the volume is orthogonal to the hyperplane normal. In other words, it is the hyperplane. Well, it's a basis for the hyperplane. Maybe I should call it, give it that name as well. So this is the hyperplane basis. You can print it. Yeah, so it's a 4x4 matrix, because I'm actually printing the proper rotation of well, how we have to rotate the universe itself, so that its first 3 axes align with the chosen basis axis. And that matrix happens to be such that, well, this is a vector and this is a vector. And they are all, each of these vectors have a length of 1, and they are all orthogonal to each other. So it's just 4 vectors that are orthonormal basis in universe coordinates, which correspond to the basis of the 3D hyper block, so the 3D space. And you can easily see why that is the case. If you would make this a column vector and you multiply this matrix with that column vector, then of course you get the length. I mean, if you multiply it like this, the result becomes this squared plus that squared plus that squared plus that squared. If you have the same values here, which is the square of the length, which is the square of 1, which is 1, and the rest is orthogonal, so you get 0 for the rest. So the result would be 1, 0, 0, and another 0, which then corresponds to the x-axis in this basis. So this is the x-axis of the basis in universe coordinates, and this same thing, y-coordinates. That would, if you put that here, you get 0, 1, 0, 0. If you put that one here, you get 0, 0, 1, 0, and then there is a completion thing to span the whole universe. But yeah, normally, well, that they get projected away, as in if you would have something that has Hey, I'm on. If you would have a vector here that has this as a component, then you get a fourth component, which we then ignore. So basically that's the same as projecting that direction away. I never touched the sliders though yet. If I do that, then this should be changing. Let's see if we can make the identity matrix. This should have no influence, and this is the orientation of my 3D space. So all at 1 radian, so that's pretty arbitrary. I think I would put all the, I mean, this is, the offset is also not used, of course, it just stays the same. These 3 angles should have an influence, though. I think if I set all angles to 0 radian, then well, nothing is rotated, right? So then 3 axes should exactly align, and we would have it would map the x-axis of the universe to the x-axis of the 3D space, and y on y and z on z, etc. So you would get the identity matrix, I think. So let's put this one to 0. Oh, that's already close. Alpha. Maybe if I understood what alpha was, or remembered what alpha was, then I would understand this. But let's just put them all on 0. And it's not the identity matrix. Or close enough, but it maps the second parameter to the x coordinate. So I would have to pick some other rotation, such that we get identity matrix. It's probably not possible by just trial and error at the very first. At the very least, I have to understand what alpha, beta, and gamma are. Let me see if I can figure that out. Do I have that somewhere in? Some ASCII art drawing, or yeah, okay. So if you set alpha to 0, then the hyperplane normal points along the x-axis. So yeah, then the 3D space lives in purely the y. How do I call these things? Because I'm gonna number them. So the x coordinate, x-axis is 0, y is 1, etc. So the normal points in the 0 direction, and then we have the 1, 2, and 3 directions are left. We saw that those 3 were exactly then mapped to the 0, 1, and 2. So if I want to map x, y, and z to x, y, and z, then the normal must point into the fourth, the direction 3. In other words, this must be 1 and the rest must be 0. Which means that we have to put that one at 0. That means that alpha must be, what is it, quarter pi? Let's try that. Pi divided by 4. I'll just run it from here. Hypercube. So let's put this on at 0.785. There's no way I can do that, but it's close enough, right? Oh, that wasn't what I wanted. It's a program already terminated. Yeah. To this one is now 0. We have to pick, well, that one is going to be 1 then. So this must be 0, which means that also beta must be a quarter pi. And then we have, this is then 1, and then this is 1. So also gamma has to be a quarter pi. Yeah. So if we put all three on a quarter pi radians, then this is 0, 0, 0, 1. The hyperplane normal points in the third axis direction, and then it should map it to x and y to y and z to z. Let's see if we can make that work. So 0.78 something. 0.78 something and 0.78 something. I'm not happy with the result. No, that doesn't look like what I wanted. It's not even close. Why? Maybe we should print the hyperplane normal, so at least you can see that this works. Let's see, pi divided by 4, that's wrong, I meant 2 pi divided by 4. So because a quarter, yeah, of course, it's a quarter of, it's a half pi, times 2. So I need 1.57 for all of them. 1.57. Well, 1, 1, 1. And the 1 here. So it maps z to x and y to y. And x to z. Why would it do that? Oh, that's pretty arbitrary, actually, I think. Yeah, all x's are almost on top of each other. But apparently the z-axis, or 0, 1, 2, so the 2-axis is just slightly more into the 3D hyperplane than the other axis. So that one is picked first and then ends up at the 0-axis. So we just, if I could tweak them a little bit, but this is per pixel, so I can't tweak anything. I can't even tweak it back. That's interesting. Wait a minute. I can. 7. Yeah, there it is. 2. It did something. What is this doing? Yeah, but around this value anyway. There's no influence on the first one. There's also no influence on the first one. It's totally not there, no influence. Yep, there it is. Okay, it should be larger than, but not that much. Come on. This is still good. No, it's artificially. I'll put it on 159, not even that. Okay, so we have this one. Well, maybe you can. Yeah, no. This one just had to be a little bit larger than pi divided by 2, and this one had to be larger than that one. So it's more or less. But so now it is the identity matrix 1 1 1 1, and the rest is 0. Hi, Mick Colonel. Yes. I probably better way should show the code right at this point. But yeah, I think it was just fun to show that I can morph this thing into an identity matrix. Blip. Okay, so these are my sliders, alpha, beta, and gamma, and they determine the direction of the hyperplane normal in the 4D space. And then here, well, actually create a hyperplane normal, like I said, and here I create hyperplane itself. And I create a subspace, which is orthogonal to the hyperplane. Okay, it's just the hyperplane normal. And then we create a basis. And now the basis, that's the basis of the hyperplane. So it is 3-dimensional. And the basis has no. Yeah, there it is. I just had to go one further. The basis is a scale factor, which I just left at 1 at the moment. And a rotation matrix. And then no one can explain it better than this comment here, what that is. So these are row vectors. It's an orthonormal basis. Okay, it's a bunch of vectors of length 1. That's a normal part. And the ortho means that they're all perpendicular. So the dot product between any of them is 0. And there are universe coordinates. That's how the matrix is built up. And that then defines our basis of dimension n. So 3 in this case. So the universe n is 4, but I'll just fill it in as being 3. Okay, man. Okay, so we have a basis now, and we can convert easily from universe coordinates to the basis coordinates. For example, you know, this x hat here is the top row, which is basically a lot of values that are not 0 or 1, but they're supposed to point in the x direction or of that basis. And if you multiply this matrix with that vector, you get this. And that then is in basis, in the new basis coordinates. But next we have theta and pi. And that is going to, those are just polar coordinates, or is that the right thing? Yeah. Inside the 3D hyperplane that we have. So the hyperplane has an X and a Z direction. And then theta is a typical polar coordinates. So the angle relative to the z-axis, and then phi is rotating around the z-axis relative to the x-axis. And that gives us a new vector, but this time a three-dimensional vector inside this three-dimensional hyperplane. And that then is the normal of the screen, of the window plane, the two-dimensional plane. And I want to apply the exact same code, but then everything one dimension lower and using different angles. And that should work. So let's begin here. First we create a vector, which is, I don't know yet, I want to use 3 or 4 dimensions. I could use 4 dimensions and then just have it a 0 there. Let's see if 3 dimensions works. And how did I call the thing? That is, it's not my hyperplane, it's my window. Good, I'm not sure I called it before. Screen, I think. Screen. Yeah, it's relative to screen. Let's use the word screen. What is in a name? Screen normal. Although I don't like screen really, but yeah. I'm gonna use a long word. I think I'm gonna use window plane. Well, that might be a bit much to use that here, so it has to be written out in the user interface. The window plane. Sorry, I'm just making it one word because hyperplane is also one word. Okay, then we have the window plane normal. And that would be equal to that thing. And the thing has 3 dimensions, and the first one is the x-axis, and then we have the, yeah, God knows. Yeah, so we have 1, 2, 3 dots. 1, 2, 3. That's the y coordinate and the z coordinate. Well, I think I know the z coordinate. That would be the cosine, right? The cosine of the angle relative to the z-axis, which was that one, theta. And then these two must be the standard sine of theta times something as well. And then the other phi was the angle relative to the x-axis. So if phi is 0, then we should get something that is totally in the x-axis. In other words, the x-axis has to be multiplied by the cosine of phi. And then this, well, I don't know, probably just sine of phi. Except that maybe a minus sign is missing here now. You know, this is correct. If theta is 0, then this is just 1, and that's what you want, and it points along the z-axis. And this would be 0, so you get 0, 0, 1, if theta is 0. And if theta is half pi, then this is 0. I mean that the normal is lays in the xy plane. This is going to be 1, and then this must be the cosine of phi, and this, yeah, this is just the sine of phi. Okay, so that works. We don't have an offset. I probably have to use a hyperplane again, though. I don't have a plane object. So this is my window plane. Constructing it from the window plane normal and a point in the plane. But we're working in the hyperplane coordinate system, right? So I think the origin of my window plane, I mean, yeah, it might be shifted. I'm going to shift it later, I think. Not even sure. If it is shifted, just shift it in the plane itself. So 0, 0 is a part of the plane. Either way, I mean, it's the origin 0, 0. It's two-dimensional. It's definitely an element of my window plane. That's like the thing has an origin, but the point 0, 0, 0, that's the origin of the hyperplane, is also in the window plane. Because maybe I shift the window plane, but I shift the window plane in its own plane. So yeah, the origin of the hyperplane is in the window plane. So I have to fill in this formula here, minus some point dot product with the normal. But my point is 0. So the dot product then is going to be 0, and the minus in front of it is still 0. So yeah, 0. Dot product is a scalar. So let's check. So the hyperplane can be constructed from a normal and some floating point type t. So we get now the hyperplane is the normal dot product with x equals 0. Yeah, so we just project n away. Yep, I think I'm happy with that. So, and this is a template hyperplane, but since I've got 0 plus 17, otherwise 20, I don't know. You can just leave that out. I mean, actually, it's something that's stuff here, but it will figure out what from the constructor arguments. So in this case, we pass a vector type, and the vector type has an n and a t. So hey, it knows the n and the t. Therefore, the n and the t are known for that type, for the hyperplane template. So it's not the same type, right? This has an n of 4, and this has an n of sorry, this is an n of 3, and this actually, no, this is an n of 4. This has an n of 3. Because that's the same, the n is the same as the dimension of this vector, so that's still 3, even though the hyperplane itself, yeah, is a hyperplane, so it's 1 dimension less than what it is working in. Now I want to create a basis for this thing. I'm really wondering where this is going wrong. It has to go wrong very soon. Somewhere. Or can I just ignore the fact that there is a universe? We are working in universe. I think that part of my code is working in universe coordinates. And it is totally aware of the universe. I mean, like right now, I think I have to pass the universe. I can't pass the hyperplane here. So we'll have a look at subspace. See, the subspace has as templates the universe that it lives in and the number of dimensions of the subspace. And then it is created. Currently I only have one constructor allowing a one-dimensional subspace only. I was too lazy to add the possible rest, so this is going to be one every time. But yeah, the normal is in universe coordinates, so we need to convert our normal first back to universe coordinates. Okay, let me just copy this. Construct a 2D orthonormal basis for the hyperplace. Oh, and I've invented a new word. For the window plane. It's still one-dimensional, but we have to pass here the window plane normal in universe coordinates. And it definitely isn't, because, well, it's a three-dimensional thing. Where's my window plane normal here? It's a three-dimensional vector, so how do you fit that in the universe? I can't use the same name here. So this is it is a subspace. It's orthogonal. It's orthogonal to the hyperplane. Just pending hyperplane in front of it. Hyperplane orthogonal subspace. Okay, so this is what I come up with when I dream it up, but it can't work because the dimension is wrong for one thing. Let's just try to compile it and see that it indeed that doesn't compile. It would be bad if it compiled. Let's see, the error comes here. Oh, no matching function for call to sign. What the hell? Oh, sorry. That is an something that needs parentheses to get actual value. Maybe it's just a slider, probably. Constructor or deduction guide for deduction of template arguments of a math hyperplane. I hold a whole story about that it would automatically deduce that, and no, it doesn't. Okay, it refuses to automatically convert my int to a double. Or rather, it doesn't know if it has to use a double or a float. It's kind of weird because that information is also in the window plane normal. I don't like it that it tries to deduce it from here. I want to enforce it on that. The type is already fixed. It should not deduce the type from this parameter. How do we do that? Well, currently you pass something and it's going to say, well, I know what it is. It's whatever they passed to me. So instead of using t here, I should probably use the type given by the vector type. Then it has to first figure out what vector type is. So the vector type is this, the math vector, which also has t passed. And that has scalar type as type for the t. Oops. You have to tell that it is a type because this is a template. Okay, maybe this works. That probably thinks, well, whatever, I don't know what this is until I know what that is. So let's find out what this is. And that then should allow it to deduce both n and t. Because, well, just part of it. And if not, I'm going to ask the AI to fix it. Seems to work. It's a different line number. No matching constructor or initialization. Yeah, okay, that's what we were after. So it says we cannot convert a three-dimensional vector to whatever this is taking. The thing that it is taking is a subspace. And the subspace takes a vector type. Which is four-dimensional, max n even. Which means that it is a universe thing. Yeah, kind of not too super readable, but definitely what I expected. Let's add that line number here. 180. Okay, so we have to convert this window plane normal from whatever space that it lives in, the 3D space that it lives in, to the universe coordinates. Now I have to think of, think up, what is the word, a new API. What would be a nice way to write that? I did already work like it for the Q-transform stuff. Maybe I had a bright idea there. I don't know. Anyway, the only object that knows how to do that conversion is the basis. And we don't have this basis yet, of course. It is the other basis, this basis. So we have to combine this one with that one till we produce this normal in universe coordinates. I would say that means that we have to pass this to that. So it's going to be something like hyperplane basis dot foo, and then we pass it. Yes. However, it would definitely read better if it was the other way around. Like I could say the window plane normal in hyperplane basis coordinates, but okay. But then I would have to add a method called in to the window plane normal, which is just a math vector. I don't want to do that. We could use some dirty trick like use that, for example. It's also a method. I think this might be readable, maybe even more readable than choosing some foo word here. As in, this converts the window plane normal to the hyperplane basis. Yeah, I mean, come on, what else could it be? I like it. I kind of like it. What is the alternative? If we would have a name for my foo method, that would be maybe just convert. Maybe hyperplane basis dot convert window plane normal. Yeah, it's also possible. This might be confused with writing the hyperplane normal to the hyperplane basis. It's not even possible. How can you write something to a basis? But yeah, it's my experience, like 50% experience is it's not set in stone, but often I find that using operators like the less and less than operator and other operators is, yeah, it's not always the best thing, you know. It's like fancy, but I would say you shouldn't do it unless you have a really good reason. And I don't think that making it look good or get the grammar of the code itself more or less like English is a good reason. So let's not do this, even though I really like it, I must say. And I think I'm gonna go for the convert then. It's also readable. Okay. Now here we have a problem. This is no longer one-dimensional. I mean, the only way that this is going to compile, leaving us 2 dimensions, is when they when we remove 2 dimensions from the universe, right? I mean, we want a window plane which is 2-dimensional, which means that the orthogonal subspace is 2 dimensions. So this must be 2 dimensions. I say, okay, I'll just make it 2 dimensions, no problem. But then how is it defined? Because my subspace is also in universe coordinates, I suppose. Let's see, this is, yeah. So we need to end up with 2 vectors that are orthogonal to the window plane. And one of them is this. And the other one is, yeah, the hyperplane normal. So I guess you just have to pass both, and it shouldn't matter in which order. But the hyperplane normal is the other one. So it's more like this. So this thing is in hyperplane. No, damn it. I have to tag stuff with, at the very least, with the basis that it lives in. Yeah, I capitalized it because the W happens there, not because it's a type. Let's make this an H as well. You can see, in this case, you can see very clearly from the number of dimensions which coordinate, well, which basis it is using. Let's see, coordinates, so that means that they are coordinates relative to the basis of. So this is universe coordinates, means that it is relative to the basis of the universe, which is just a standard basis. But I'm gonna take it. It's something I learned somewhere, that if you work with coordinate systems, it is an absolute must. You can't even rely on type safety. You really have to include the coordinate system in the names. It just, you know, I'm not even thinking about it anymore. I want to have it. A tag that shows me which coordinate system it is. It is, of course, only really important when they live in the have the same number of dimensions. You can do coordinate transformation within the same space. It's not as important now, but well, let's get used to it. But for now, let's tag only the. Yeah, no, maybe the hyperplane itself is more abstract. I mean, it's internally it stores stuff, but it can store it in any coordinate system. I don't care. The thing itself doesn't really have a coordinate system, I think. Or, well, it introduces a new one. But no tagging yet there. Let's just check the vectors. It's only those two, of course. To my conversion here is needed to be converting to UC. If I see my matrix as a hyperplane base, I mean as a matrix, then I'm also tempted to use a multiplication. So this is a side comment. So using coordinate transformations, you're supposed to do stuff like for a coordinate system is AC bar BC times BC bos. So then you have this. Wait a minute. That is AC. If I use foo here, I should use foo here as well. Well, this is then the conversion. Anyway, the point is that I use a prefix and a postfix, and then those two are allowed to be multiplied. So there must be BC here and a BC there. And then if you do the multiplication, then they are removed from the equation, including with whatever you did. So then we end up with AC foo. That makes it readable and that you make no mistakes. I'm trying to bring that into here, as in, just like here, I want to pass an window plane normal, but it must be in universe coordinates, because this thing just takes universe coordinates for every argument. But we have this, so I must convert the underscore HC to an underscore UC. I think I'm going to look at, try to find back my project where I had this. The last thing that I did related to coordinate transformations. It's maybe in here. Something with coordinates. No, that's so brilliant. Oh, that's what I no. Nope, I have no idea. Definitely had Q transform in it. Hopefully I'm writing that correctly. I don't think it's in projects. Actually, it might be in C++. Nope. Okay, I'm gonna gamble then that it is in here. This also makes no sense. Well, it is about Q transform, so yeah. Hello, status videos. I'm still coding. Not as much streaming anymore. My memory is still bad. Trying to remember something that I can grab for. Something with coordinate systems. You think the word coordinate system is maybe part of it? Builds, codex builds, transform builds. I wrote not. I mean, the last a few months ago or something. I wrote something that did coordinate transformations, and it worked while having an enum with all the coordinate systems in it, and then you could pass that as a template parameter. If I could only remember a single coordinate system abbreviation, for example. Nope. Well, I'm getting depressed about this. But not giving up. Now I want to find it. I don't think it was transform. Did do that after. Oh no, now people can see the name of my private. So much for privacy. Hitachi core machine learning events. I would say this is the one, yeah. Yeah, this is too far back. Way too far back. It's either math or transform or cairowindow or in chess. No, I can't remember anything. The only thing I remember is that that I was passing which coordinate system it is by template parameters, as template parameter. No, I do not have paid job, no. Find. Okay, it's one of those, right? So, well, no. Things that I just mentioned. So math. Math is in math is in here. Well, everywhere basically. Transform. Transform is also in here. Transform is in inches. Okay, what we have it. The inches is also in there. Cairowindow is also in here. Yep, it's definitely in this direction. So now I'm going to brute force find. Unfortunately, it takes so long because I have gigabytes of binary stuff in it. So probably type F. I think we'll concentrate on just headers maybe. Say name. Well, that should be enough to find it. Execute grep all files that have, well, let's first print them out. Q transform. I'm not 100% sure actually that my coordinate transformation already was used in a project that is using Q-transform. let's instead search for minus I coordinate system. Ah, I think I have it found it. Yes. So it is in transform. Yeah, we're passing coordinate systems as template parameters. Yes. So here you see an example there where this short circuit thing happens, and including the transform. So you have this variable times that variable, and then this drops out, and then you are left with CS origin underscore pixels. And now I finally remember that, yes, I had the word transform instead of convert. I now feel that convert is a better word, to be honest. Yeah, so that also means that I have prefixed them. So why is this prefixed? Oh, that's prefix endpoints. Sorry, this is the transform thing. They are, oh yeah, they are post fixed, which means that you have to multiply them on that side, on the right side, with the transform. I thought I saw a transform that did it the other way around. That would not be possible. Yeah, I think I picked this order because that's how Qt transform is doing it as well, as in the order. They multiply from the right with their matrices. Let's hope so. I think, yeah, because otherwise I would have put it in I think I put the transform matrices on the left. So the fact that they are on the right now is because I changed it, and I changed it because that's done more like how Qt is doing it. Let's keep that for now also here then, which means that we do have a postfix for the coordinate system, and then the transformation must be done by multiplying it with something. So for example, hyperplane basis. So I just use transform here as well. Convert also got that it reads equally bad. But this reads, yeah, very good. As in, we have the window plane normal in HC coordinates, and we need UC coordinates. Therefore, I multiplied with HC transform UC. But then what is this type? Well, it has to be a matrix. And this is a vector, and I don't have matrices. I think I have to implement a matrix then in order to get this. But then don't I already do that? Have that? These things should be matrices. Oh, they are transform objects. That's why they are called transform, of course. They wrap a Qt transform object. That is, yeah. So maybe not use transform then, because this is not a transform object. It's going to be something else. Just call it do. HE2UC. And that must then be a thing that can be multiplied from the right with the window plane normal. HC. Which is a math vector. So now I need suddenly a matrix that I can multiply with vectors from left and right, and probably transform and not transform. Transpose. Take the inverse of it. All kinds of stuff. Yeah, that you would start to wonder. It's just going to be a thin wrapper around an eigentype. Do I really have to define my own class for this? In the end, it's always handy. I mean, I define stuff like this, which I wanted to have for some reason. Mostly because of this. Treat the points and vectors differently. Okay, let's do this. So we go to math, create a matrix. Copy vector.h to matrix.h. I know if I'm going to need them, actually, but. Strip, strip. No, I don't need a direction for the matrix. Typically you would want n to be rows, or rows first, row call. So you have one column, so my previous vector was an column vector, what I'm quite happy with, I guess. Yeah, find that back. Jigs machine. Oh, I'm just looking for this, of course. Think. Oh, it's after the const. Right. We have a matrix of 3 rows, 2 columns, and we multiply it with multiply with the column vector, 2 rows from the right, get a column vector of 3. Now we multiply it from the left, so I have to interpret the vector as a row vector, which means that the number of rows must be, sorry, the number of columns must be equal to the number of rows of the matrix, which is the first argument. And then the dimension of my vector in this case is window plane normal HC, which is 3. I think. And we got this one from that was the HC2UC. That is the first basis that I created, this one. A bit vague, but we'll see. Path vector is still in there. Why is it including vector? At the end, nobody will know. I think I should just include vector at the top, because the vector is not depending on matrix. It's a matrix version later. So no reason really to use a forward declaration of the vector. Plus, it does fix the headers as well. So I removed already a few, but type traits was also no longer needed apparently. And negated, yeah, definitely not inverse matrix. It should also not be in vector actually, the word inverse. Could probably already change that. I don't think it will edit that file. It's already done. Okay. Yeah, I disagree with that. I don't definitely not want automatic conversion to eigentypes. Well, I thought I think I'd replace it. I just added this. Okay, I still disagree with adding it. I don't want suddenly to get alien types from eigen library in there. Oh yeah, I was planning to fix that. I see AI saw this. The const was, the requires was on the wrong side of the const. Well, if eigen calls a determinant, then I want to call a determinant. Because I only used that because I thought the eigen was doing that already. So let's change this to determinant as well then. Oops, I'm still left in the V. Okay, so what can we do? Add another matrix. Subtract another matrix. Multiply the matrix with a scalar. Divide a matrix by a scalar. Multiply with another matrix. So it's using this here, and now suddenly it switches to using eigen. I think normal is that you just use the axis that you have when you have the axis. And I think we have the axis because this is just a member function. So let's stay consistent. So it transposes the whole matrix. So isn't it faster to transpose the vector instead? Is that not how it works? Yeah, of course it does work like that, because it's just the vector is also a matrix in eigen. It seems a lot cheaper to transpose the vector, which is exactly what I intended anyway. Just interpret the vector differently. Still multiply it. I mean, in this case it doesn't matter if you multiply it from the left to the right, because it's just a matrix over the reals, but yeah, I don't think this works, because, well, very maybe? No, it doesn't work. I mean, we're calling a member function on V, which is a vector, so it's definitely vector must already have been defined here. You can't include it at the end. I'll just include it at the top, because, well, we need to include it anyway. Also not sure why why the vector is using this. Yeah, the matrix is going to be included from whoever is returning my matrix here. That is the hyperplane. We don't have that function yet, but the rest should already work, I think. Oh, wait a minute. I know I don't have my matrix yet. Hyperplane. The hyperplane was the one. Why hyperplane? It's kind of weird. No, it's nonsense even. I don't want to use hyperplane. Must be a basis. Yeah, and that is a basis. Hyperplane basis. The basis defined here. And this should then. Oh boy. Yeah. Okay. Now we have circular header dependency. Or not. Actually, no we don't. This is universe. Okay, so we can just include matrix here. Let's put this a bit low, no, higher of course. The newer the higher. No matching constructor initialization of moth subspace U2. Okay, subspace universe ID 42. Candidate constructor not viable, requires single argument normal. Indeed. I have not fixed it. Subspace is now constructed from 2 vectors. No, yeah, before I was too lazy. So now we have a normal 1 and normal 2. Yeah. Wow, that compiled. No, let's add this one. HC to UC. Okay, that's nonsense because this file defines what that is. Although UC is universe coordinates, HC is hyperplane coordinates. This has nothing to do with the hyperplane. This is a basis. I think it just always goes one way. Well, it goes one way or the other way.